Without any further ado, I'd like to introduce you to Adam Armour. He's our CTO here at Breebug. He is currently working at MapQuest, doing an amazing job down there for them, helping them redo really MapQuest, if you will. And with that, I'll go ahead and kick it off. There you go.
All right, thank you. So, hello, my name's Adam. Try not to do anything weird in front of the camera. Or maybe I will, who knows. So yeah, again, these slides are online. If you go to github.com/Breebug Consulting in our presentations repo, we've got all the slides from our past presentations. So I'm going to talk about Redux, mostly Redux, and we'll talk a little bit about using Redux with Angular. But I wanted to kind of keep this focused on sort of the high-level concepts, independent of the particular Angular implementation. But we'll talk about a couple of the popular ones that are out there. So Jesse's comment was prescient. So who here has heard of Redux? It's pretty much everyone. So who's using it on an actual project right now? All right, so we got a couple. And if it's an Angular project, are you using like NGRX or NG2 Redux? Okay, cool. So we'll talk a little bit about NGRX in particular. So I want to begin with just stating that you might not need Redux. It's been fairly popular, a lot of blog posts. It's pretty high on the hype train right now. But I think it's important to understand that it may not be the best fit for now. Usually when these things become popular, everybody sort of rushes into something thinking that it's going to solve all of their problems. So there's a good article I linked to here from Dan Abramov. If you're familiar with React and React Router in the React community, he's done a lot of work, created the Redux pattern. But he's got a good article that kind of covers some of the reasons you might not choose to use it. So for one, for a small app, it's probably overkill. A lot of people get into, all of the pieces and wonder why they have to change 3 files, to add a new feature or, do something that, deal with all this boilerplate and things like that, which may not benefit a tiny app. However, as your application starts to grow and you're dealing with more complexity and application state, it becomes something that can help scale your app. For many small apps, they'll scale just fine without Redux. There may be a bit of a learning curve for developers who aren't as comfortable with functional programming paradigms. Though I would argue, as JavaScript programmers, I think it's important that we be comfortable with the functional paradigm. It's very much a part of the language. We've seen certainly a reemergence of functional programming within the past few years, and a lot of that has been driven by React and Angular, what's come in Angular 2, observables, RxJS, things like that. But depending on your team's background, there may be some overhead in getting people up to speed. So it also imposes some constraints. So the application state needs to be represented using plain objects and arrays so that it's serializable. And we'll talk a little bit more about what this means and what these constraints are all about. But it does impose, by implementing this architecture, we take on the liability of dealing with these constraints. And in the case that we don't, you begin to lose the benefits. And then you've added a layer of indirection that doesn't really give you anything. So we'll see that changes in the system are also described using plain objects. and all of the logic for handling changes needs to be implemented as pure functions, as we'll see when we start to talk about reducers. So let's see. So with that in mind, a simple app might look like something like this. We tend to have some views and some data that we're providing to those views. But as an application grows, we tend to end up with copies of that data. As we have more and more components, this data becomes harder and harder to keep track of. And as the user is interacting with an application, it becomes difficult to keep track of how that data is changing and flowing through the app. So, in other words, as our app grows, this tends naturally to become more complex, and we have different ways of dealing with this. For example, in the case of having many components that are not related in a parent-child relationship, we may need to communicate between those components and share data. We can do this in Angular with services or eventing, and Angular 1 apps, if you've ever used broadcast events on the root scope to keep components decoupled, you probably run into this case where it becomes very hard to know who's emitting those events, who's subscribing to them, who's changing what data. You throw in two-way data binding, and it just becomes, at some point it becomes just a spaghetti mess. So this was a problem that Facebook ran into, and really, they built an architecture to deal with this problem, and this is what they called Flux. So it's an architecture. It's not an implementation, although there are libraries for implementing Flux, both for React, Angular 1, Angular 2. So Redux is basically a simplified version. So instead of, let's see, I'm missing a... Yeah, so Redux is basically Flux Lite with functional programming applied to it. And we'll see, what that looks like. So the major benefit of that Flux introduced is basically transactional state management. So instead of dealing with application state all over the place, we actually isolate how things change from how they look. So this has a number of benefits. One, we have deterministic state, meaning that we always know what our state is. So if we imagine our UI as as a function that takes as an argument an object, right, an application state. In a deterministic, if it is a pure function, it will always return the same thing. So if we imagine that our UI is a function that returns a DOM, we can always give it a state object, and given that input, have the same view every single time. And that predictability gives us a number of benefits in terms of testability, reproducing the same view, and not dealing with unpredictability. So I mentioned that the state is a plain JavaScript object, meaning that it's serializable. So we can take that state and persist it, and at a later time boot the app from it. And if it's deterministic, we'll always have the same thing given some initial state. So again, if we can serialize some initial state snapshot, as well as a series of user actions, which are also plain objects, we can take that snapshot, replay those actions, and reproduce a scenario. So For example, if a user is interacting with your app and some error occurs, we could take that state snapshot, all of the actions that led up to the error, serialize those things, send them off so that a developer can later take that and reproduce, replay that scenario. So it's it's roughly analogous to using Git, right? We have a series of commits. We can go back in time and look at some previous change. We can take a change set and apply it and reproduce that state at any given point in time. So this also facilitates being able to maintain an undo history, what's been termed time travel debugging. So I want to show quickly the NGRX example app so that we can kind of see what this looks like. So this is available in the NGRX repository, and it's meant to be a showcase of all of the pieces that make up that platform. So on the left, this is the application running in the browser, and on the right, I'm running a Chrome extension, which is the Redux DevTools extension. And what it's showing here is, on the left, all of the actions that have occurred thus far in the app. So I can do things here, and you'll see that as I'm interacting, that we're actually dispatching a number of actions. So I can select on something, and we'll see that there's a new action in the list. Down here, I have a timeline, so that I can actually step back through all of those actions. So all I'm doing again is taking some state, passing it through my component hierarchy, and regenerating the view. So I can go forward and back and see, basically replay all of those actions. On this right panel here, we're actually seeing the diff in the state. So we'll come back to this as we start talking about some of the pieces. I can actually look at the full state object and see what I have at this particular point in time, and as I step through, see those changes. So again, this is the object that could then be serialized. I can download this thing, I could export it and save it to a file and ship that off. If I wanted to, at some later point, reproduce this particular view. So, in summary, this is what we're trying to get to. This is being able to do these kinds of things is why you would choose to, to consider using Redux. So, as our user workflows become complex, or when we have disparate workflows. So if you have a large app, for example, that has many roles, if there's a regular user, administrative users, or different parts of the app that are only accessible to certain users, those kinds of things, those workflows tend to become fairly complex fairly quickly. Similarly, when we start to introduce real-time data, so if we've got WebSockets or server-sent events, we want to be able to deal with that asynchronous data that's coming in and be able to manage it in a sane way. Similarly, if we're fetching data from multiple endpoints, API endpoints, to build up a view, if you're making 4 or 5 calls to get data and we need to coordinate between when this piece of data loads, we need to update this thing. When this piece of data comes in, we need to update this thing. So if you imagine all the things in a complex app like Facebook, right? You've got nav bar, notifications, lists of users, real-time messaging. So all of these things were the motivation for moving to the Flux architecture. So this is just a high-level overview of that architecture, and we're going to talk a little bit about some of these pieces But I think the thing to note in this diagram is that data flows in one direction. So we never have, an arrow pointing in both directions between any two of these boxes. And that's something that's very important. The unidirectional data flow is a core piece of being able to manage application state in a predictable way. So, similar to Flux, the core concept is that we're dealing with a transactional state model. So we could see that in the example app. Essentially, we have a state at some point in time. We dispatch an action, which is an object or an entity that describes something that happens in our app. Then we pass that through a reducer, whose job is to take an initial state or the previous state, apply that action, and generate a new state, so that we arrive then at the next state in our app. It's similar to like a bank transaction. If we have some given state and a list of actions, we can produce any future state from those two things. So, keep this in mind. This is kind of at the core of what gives us predictability. Also note that this is a serial and synchronous process. So we move from state to state linearly. We'll come back a little bit later to talk about how we deal with asynchronous processes like fetching data from an API. So we'll start with actions. Actions are pretty simple. Just a plain object. By convention, they have a type. In this case, this is the type is just some constant that evaluates to a string. And then we have some sort of payload. So this is all the data that comes with the action. So in the case of the canonical, to-do list, we might have an action to add a to-do to the list, and we need, the content, the thing that the user will eventually do. And so when we dispatch an action, this is what we're emitting. It's just a plain serializable JavaScript object. It serves as basically the record of the state transaction. So the action is, says what happened. And it's the only source of information for the store. So the store, and we'll talk more about what the store is, but it's essentially our source of truth for the application state. If we go back to the Flux diagram, you can see that actions are dispatched, and it's the only way that we can get data into the store. That means that when we start talking about components, that components themselves are never, say, mutating or changing the application state directly. Everything is dispatched through an action. So where actions describe the fact that something happened, they're just data. They don't deal with actually changing anything in the state. This is really what the job of reducers are. So a reducer, so in Redux, we really have one function that is, we have a single reducer, a root reducer. And it's a function that takes the previous state object as well as an action and then returns the next state. So, obviously for a large app, trying to manage everything within a single function should seem obvious that that's not sustainable. So we actually can compose reducers. when we look at the store, we'll see an example of the state object, and we can look at it in the example app. So there's quite a bit in here. We have data for searching, the IDs for previous searches, all of our list of books, the actual entities which represent the data for an individual book. So this gets quite large. But when we, depending on the implementation, basically every implementation or most of the implementations of Redux provide a way to compose reducers. So we can break down our application state and create smaller reducer functions that only deal with some slice of the state object. So we may have a reducer, for example, that only deals with books, and a reducer that deals only with the collection or things related to the layout. And then we compose those into a single root reducer. So there are a couple properties that are pretty important that are invaluable characteristics of reducers. So we can't violate these constraints. One of them is that reducers must be pure functions. So what I mean by that, if you're not familiar with the term, a pure function is one that, given a set of inputs, will always return the same output. So within that function, we can't create any side effects. That means that, for example, we cannot mutate the state. The state object that comes in, we can't push data onto an array. We actually have to create a new object that contains the new data or the changed data. And they must not produce side effects, meaning that within a reducer we can't call an API. We can't do things like call non-pure functions like math.random, because those will cause our function to be impure. We don't get the same output if we call that function repeatedly with the same input. So those are hard constraints. I think for people who are new to Redux, that sometimes tends to be a point of aggravation when you say, why can't I make an API call in a reducer? Because you can't. Don't do that. But it's important because, again, the purpose of using this architecture is predictability, and side effects are unpredictable. So we keep all of our side effects outside of the reducers, and we'll come back to that a little bit later. But so the store, once we have, the store we can think of as more or less like a database on the client side. It's our source of record for the application state. So in Flux, where you could potentially have many stores, Redux has only one store. There can be only one. There's one state object, and we only ever deal with a single object. So, we took a look at that in the example app, but this is another. I pulled this, I think, from there. So our application state is a single object, and it's a plain object, meaning we don't have things that are not serializable as JSON. So it doesn't have functions or anything like that. And this is all of the data that we need to build our view in the application. I should mention that this excludes transient UI state. So we may have components, say, if a user is filling out a form in a view, we may have some form validation, things like that. the user might need to, say, submit that form before that data is persisted. So not necessarily every piece of state in your application would be part of your application state, but generally we can think of the things that are persistent. So, for example, if you refresh the page, the data that would be there, or if we're generating views on the server. So again, these three things are working together to basically transition from state to state through our app. So as the user is interacting, we're dispatching actions. They're going through reducers, which take a state and an action and produce a new state. And we, repeat this process as the user interacts with our app, or we receive events from the server, anything that would result in a state change. How are we doing so far? Any questions so far?
You're doing great.
All right, thank you. So that whole process deals mainly with what's happening, how things work. We also need to deal with the presentational aspect, which is how things look. So generally speaking, these we can divide all of our components in our app into two categories. So, if you're familiar with React, everything is a component, hierarchy of components. Same with Angular 2. Our entire app, starting with a root component, is just a tree of components. In the Redux world, we have what are known as smart components. These are also known as container components. I think there's a few other names out there, but generally they're concerned with how things work. So these are the components that listen to the state changes. So they're going to be subscribing to the store. So in the case of NGRX, they're going to be listening to the observable and responding to the events that are being emitted when a state change occurs. So, thinking back to that diagram, every time we go from state 1 to state 2 to state 3, we're emitting an event that says the application state has changed. The components that are listening to the store can then take whatever part of the state that they care about and propagate that down into their child components. So in addition to listening to the store, there are also the components that dispatch actions. So they're the components that know when to signal that something should change in the application state. And if you recall, we never touch the store directly. We don't change the state directly. We simply dispatch actions. Those go through the reducer process, and then the store will emit the next event indicating that the state has changed. So this process is happening continually as the user is interacting, or other events that result in state changes, like a timer expiring, if we get a response back from an API, etc. So we also have dumb components, and these are also known as presentational components. They tend to be stateless. They're concerned with how things look. So if you imagine, some good examples are Angular material, the material design components, or something like Bootstrap. Those are components that are designed to be reusable. They're not really concerned with the business rules of our application. They may be concerned with things like dates and calendars and stuff like that, but they tend to be highly configurable, highly reusable. And so those things aren't dependent at all on our application state. They get all of their data from something else, from their parent, something that knows about, and that something is our smart components. And they also don't dispatch actions. Any sort of change would be evented up through their event emitters, so that the smart components that compose the dumb components can be responsible for dispatching the actions. Typically, a typical app, I think, will tend to have more stateless components, more dumb components. And oftentimes these things will be further down in the component hierarchy, but it's not necessarily true that they are always children, or that they don't have smart components as children. So, for example, the material design layout components, the side nav component, is a dumb component, but it may, in its containers, have smart components that contain some substantial part of that particular view, for example. So there's some good articles out there. I included some, I think, in the references that discuss a little bit more about what are smart and dumb components. But essentially, the entire app is a hierarchy, and we've isolated all of our state change to the Redux process, so that anytime we want to make a change, we can do so through the actions, and we simply wait until the store emits an event that lets us know that a change has occurred, and then we can simply re-render our app. So the hierarchy, that component hierarchy, is essentially the UI function that I mentioned, right? We can take some state, pass it to that root component, and let that data propagate down. And that's how we're able to rebuild these views as we move through the app. So I wanted to come back to async actions, because this is one of the advanced topics, I think, that comes up, and it comes up pretty soon. So we've been talking about this sort of the synchronous process of moving from state to state, but we have to deal with asynchronous processes. If we make a request to an API, that's a side effect, right? We don't know when that request is going to complete. We don't know if that request is going to be successful. Something could go wrong in the server, and we don't get the data back. So we need a way to deal with that unpredictability and still, not blow up our nice synchronous transactional state model. And so the way to do that is through async actions. To some degree, this is an implementation detail. How this is handled is influenced by the particular Redux library. So NGRX, for example, has a companion library called effects, and its job is essentially to take actions and transform them into other actions. If you read the original Redux documentation, they talk about middleware, which is another mechanism that was actually implemented originally in the NGRX library, and then for whatever reason they moved to the effects approach. So terminology, you may come across that term middleware, but it's an implementation detail. But if we imagine that we have some action that represents an asynchronous action, like fetch post. So if we want to fetch a list of blog posts from the server. This is inherently an asynchronous process. What we need to do is take this action and transform it into a series of actions so that our UI can respond and render itself in a way that represents the asynchronicity of that process. So this is this shows again a number of states, and we're showing just a simplified state object for each of these, and then the actions that we end up dispatching. So if we imagine starting with this object, we have not fetched anything yet. We haven't initiated any API requests. There's no errors. We're not loading anything, and we have no posts. So we can transform that fetch post action and initiate the request, and then dispatch an action that indicates that we've started the request. So our next state will indicate that we are currently loading, and the rest of the application in terms of the view and the UI doesn't care that we're waiting for a request. At some point the request will complete, and it will either be successful and we'll get the data back, in which case we can dispatch a success action and transition to state S3. So in this case we have no error, we're not loading, and we have a list of our posts. In the alternate universe where our request failed, we can issue the failure action, and that will pass through the reducer, and our state will be that we are not loading, but we do have an error and we have no post. So if we look at the a hypothetical user interface for those particular states, we can see that before we've initiated a request, our button is active. The user clicks on the button, we dispatch our load post action, which is then transformed into the first action, which is make the request. And at that point, we have our state object, which says that loading is true, so we know to render the button with the loading text and disable. When the request completes, we're going to transition into one of two states based on the result of the request. So either we have our posts and we can render them, or we don't, and we can change the state of the button to let the user try the request again. So that's more or less how we deal with asynchronicity, while the processes of actually fetching the data is an asynchronous process. Our UI state remains synchronous and serial, and again deterministic. So in a testing scenario, we can disconnect all of our things that deal with making API requests and fetching data, and we can use fake data to transition our UI, to test our UI. If we wanted to do automated testing, we could stub out that data on all those requests and still be able to test the user interactions without actually having to worry about servers, and those kinds of things that make UI testing difficult. So I wanted to finish up just by talking a little bit about the particular implementation, NGRX. So NGRX was built on RxJS, so it's powered by observables. It works very well with Angular. It seems to have a pretty good ecosystem and a fair amount of community support. There generally tends to be, at least in my experience, I found more help and information for NGRX than some of the other implementations. So the store is the primary piece, And then there are a number of companion libraries depending on what you need to do. So again, effects is a side effect model for dealing with all of those action transformation and other things, the other unpredictable pieces. Route store binds to the Angular router so that we can see the route path. We can actually see that in the example app. So as we change, we have the URL information in our application state as well. The store dev tools is the instrumentation library, which we can turn on for debugging and doing these time travel debugging and things like that. So I mentioned that the reducers need to be pure functions, and by itself, this is left as an exercise to the implementer. So there's nothing built in that will prevent you from, say, mutating the application state. You could, for example, bring in a library like immutable.js if you want to enforce that you're using immutable types. Then you'll know you'll get errors if you try to mutate. And grx store freeze is a serves a similar purpose in that we can load it up in a development environment, and it will throw errors if you try to mutate state in your reducers. Generally speaking, I would recommend probably having something in place because it's fairly difficult to manage through discipline alone, like pure, holding developers accountable. And then again, the example app showcases many of the capabilities as they relate specifically to NGRX. There's also Angular Redux, which I believe was formerly NG2 Redux. So Angular bindings for Angular 2. There's also an NG Redux if you happen to be still dealing with an Angular 1 app. Those are bindings for the Redux libraries. And so that's all I had. Wanted to open up for questions, and I glossed over some things, so we could go back and talk about some of that. But yeah,
Is there a continuous digest cycle happening, or is it all just pure like, here's your action, and then it triggers a state change, and it goes and looks and sees and says, hey, I've changed. Go ahead and implement all the changes.
Yeah. So there is any time that the state object changes, the store will emit an event, and then it's up to anything listening to the store to figure out what they want to do with that data. So if they're pulling data off of the store and passing it down to child components, that will potentially trigger the change handling logic. So one thing I didn't mention is that because our data is immutable, we can take advantage of some of the performance optimizations in our components. So we can opt into the on-push strategy in Angular 2. So that data every time will be flowing down into our component hierarchy, and then the components that need to change will re-render themselves. But other than that, the benefit is that we don't really have to care about how those things are happening. We just care when they happen and which things get what data.
How are you guys handling implementing Angular 2 with services? Do you abstract it out and put your
Redux calls and your action dispatchers and everything in a service, or you just put them directly in the components?
Yeah, so I think it kind of varies. I'm not sure that we have one standard approach, but I think typically, and we have, so one of our current projects was we didn't set up, and we're doing some work now to sort of standardize how we're going to set these up, but the typically we'll have a module to manage all of the application state pieces, so we can define define all of our actions, define all of our reducers and side effects and things like that, and then bring that module in so that the smart container components, we could even put our container components into that module as well, because those are the only things that are going to be dependent on the store and the actions themselves. There is so in the example app too, I think provides a fairly good pattern for how to lay out the module. Maybe. Oh dear. Well, I made that bigger.
It's about the tree.
So, yeah, I mean, it's, so in the example app, they're grouping things by, typically the containers will have a smaller set of container components. Things like reducers we would generally want to keep together, because those are all part of the same root reducer that gets composed. So more or less, I think we've been following this pattern. But there really aren't that many services that we're building outside of what's being provided by the core in GRX. So most of our other things are just outside of the Redux pieces. Which file? Yeah, I mean, was there one specifically? I can show you any file you want. So, I mean, we can look at some of the interesting things are the reducers. So again, these are functions that take in some initial state and an action, and then depending on what the action type is, it will do something for its piece of the state. So these are individual reducers that in the top level component or the index, we're importing some helpers that are provided by NGRX. So the compose function, for example, combine reducers. So we're importing all of these reducers, and then we have a single interface that composes the interfaces from each of these sub properties of the state, right? So we have a singular interface that represents our entire application state. Similarly, we have a single, we have all of our reducers. These are the root properties, which are then being composed into a single function. So the export of the reducers module in this case is our singular function, which delegates to one of two reducers depending on which environment we're running in. So we, in this case, the development reducer is bringing in store freeze, so that we're not, we're ensuring that we're not mutating our state. and then it's composing, these two functions to build a function which then becomes the reducer that we delegate to. But in the end, it's just, it's a single function.
Sorry. So are you guys putting your async calls inside your actions?
No.
How
So actions are just messages. They're just objects that describe the thing that happened. This is where, let's see, so the effects is where this would happen. Let's see. So I think this one has a service, the Google Book service, and I don't know what it does, but it's down here. So presumably this thing is making some API call. This is just a service. It's not a Redux thing. But we can see it's making an HTTP call here. So retrieve books, search books. But the side effects, so we've registered a side effect for a type of action. It's action type search. So this is the action that would be dispatched. This thing basically gets in front of the process. It's in the pipeline. So when an action comes in, it's going to pass through the effects module. And it'll pass through every registered effect. And at least I think that's how it works. So basically this effect says all I care about are actions of type search. And when I have, when that action comes in, we're going to do a few things like debounce and map, the payload. But at some point, we'll actually, make a request. Actually make the API request. So that's what's happening here, or we return basically an observable that will then resolve those subsequent actions. So depending on what they want to do, I haven't looked at the example in a while, but it's essentially they're going to dispatch an action when it's complete. If it's successful, it will have the list of books, and if it fails, it's going to have just an empty array, so an empty list. So that's where all of those kinds of things would happen. If we need to transform actions to basically transition through multiple states that represent an async process, it would happen in there.
So your advice against mutating the app state. So obviously, every time the state changes, you have a new object coming out.
Right.
Does that have an impact on performance? Because I know, we're discouraged in JavaScript from creating new objects, all the time. I've noticed using the Redux dev tools, if I'm maintaining my history and I go through a ton of actions, things start to really slow down. And so, what's the performance impact of that immutability?
Yeah, so some of that may be related to how much data is being saved through the instrumentation. I'm not sure. I haven't seen that, but but generally, it's typically not your bottleneck. Same with storing the entire state in memory. If you're running up against that kind of limitation, then it might be a question of what exactly are you doing, and is this the right fit, right? But I think generally it's negligible. Yeah.
So it works with plain objects and arrays. Can you expand on that? Could I use an object of the type of class, in my store?
So you probably wouldn't need to. I mean, I don't think there's any reason to use anything other than just an object literal, right?
So what if in this sample application, what if I had like 15 items in the book class? Would I serialize them into like plain JSON objects before I put them in my store, or would I put them in my store as books? Like,
Yeah, so I didn't talk too much about how to model the application state. So one of the considerations is that, I said that the store is kind of like a database, right? And we want to be able to select things out of our database, right? And we also want to be able to update it and change it in a way that doesn't itself become terribly complex. And so typically, I think the recommendation is to normalize that object as much as possible. So, for example, if you say have a list of books, we may store in the collection of books a list of IDs. And then separately store the entities themselves, where the ID is the key. So if we have an object literal, the book ID is the key, and the value is the actual data for that book. And we do that because if that data changes later, we don't want to have to find all the places where we stored nested books. If the title, for example, changes, we don't want to have to find that title in 4 different places to update the application state. So that normalized form makes that easy. So I think in the process of doing that, you end up, taking whatever instance you have and transforming it. Certainly you don't want things in your application state object that aren't serializable. So if you're doing something funky with, proxies or getters and setters and stuff like that, if you break that constraint, then you're going to lose that ability to save off your state and restore it later. I know I think there are some helper libraries that are available that will make doing those things easier. Normalizing JSON responses from APIs and things like that.
so if I wanted to stamp out like a bunch of book instances from what's in my store, I would do that post-store probably somewhere.
Yeah, probably. Like you're taking what's, you would select something, you're going to select what you need, what that particular component needs, or that component hierarchy. So the smart component, is going to take those things in the, let's see if I can find this. So one of the things that's in the example app somewhere, and I don't remember where it is this idea of building composable selectors that makes, you can write basically functions that extract, slices of your state out for the smart components.
Test in this project?
Test? Yeah, here's one. Next question.
I guess I'm just curious to see if the standard approach is fire the action and then check the state object to make sure that all expected properties have changed.
So, a lot of your tests are going to be not exactly sure what you're getting at, but we can test the reducers in isolation by passing in the action in some state, and then we can verify that we get the expected output. So that's actually a benefit. It makes those things really easy to test because they're just pure functions. Like there's no Angular at that point for the most part. You know, a lot of this stuff. So it's kind of important too to separate, you know, the ideas behind Redux from the implementation details. So NGRX is popular, but it's not the only implementation. You don't have to use some third-party library. You can take the concepts of, you know, decoupling what's happening from how it looks. So that's kind of a nice aspect of it, and I think you know, Dan Abramov in his Medium post covers that. You know, people get into it and they get angry that like functional programming and Redux like it caused all these problems, but you know it's probably not Redux to blame. It's you rushed into something and you made a bunch of assumptions.
So it appears that you have a reducer like in this books instance, right? There's a reducer for a book. If I were to switch books and say incidents, like you're doing a ticketing system, and you have participants in that are part of the incident object, you don't have a reducer for participants and a reducer for the incident. You would just do that with the incident reducer while updating the array or whatever it's hosting for the participants. Did you follow that?
It sounds reasonable. I mean, I think you know it's sort of left up to you to decide how granular you want to make your reducers, because you can compose them in pretty much any way you need to. But the idea is that you know once they start to grow and you have like 50 case statements. You know, like one big switch with 50 cases in it. At that point, it makes sense to decompose. But there's nothing in Redux that says you have to do that. You could, if you wanted to, write one reducer and build it that way. I wouldn't recommend it, but so I think at some point we'll do a talk about specifically NGRX and dive more into the implementation details. But we kind of wanted to keep this as a high-level overview. All right. Thank you.